For centuries, classical science rooted in Newtonian mechanics stood as the bedrock of scientific understanding. It described a universe governed by deterministic laws, where objects move predictably and cause and effect relationships were absolute. This paradigm reigned supreme until the early 20th century when quantum mechanics emerged, challenging long-held scientific dogma and igniting one of the most profound intellectual battles in modern physics. Classical mechanics, developed by Isaac Newton in the 17th century, portrayed the universe as a well-ordered machine. In this framework, if one knew the initial conditions of a system, such as the position and velocity of an object, its future could be precisely predicted. Determinism was the cornerstone of classical physics, and this worldview extended into other fields like electromagnetism and thermodynamics. However, as the 19th century gave way to the 20th, cracks began to appear in this long-standing structure. Quantum mechanics introduced a universe governed not by absolute certainty, but by probability. Instead of particles having well-defined positions and velocities at all times, quantum theory suggested that they existed in a plurality of states, only taking a definite form upon measurement or observation. Werner Heisenberg's uncertainty principle further challenged classical thinking by stating that it was impossible to simultaneously determine both the position and momentum of a particle with absolute precision. This new paradigm was championed by figures such as Niels Bohr, Max Planck, and Erwin Schrödinger, whose equations describe the probabilistic nature of atomic and subatomic particles. However, not everyone was ready to embrace this radical departure from classical thought. One of the most vocal critics of quantum mechanics was Albert Einstein, a towering figure in 20th century science. Ironically, Einstein himself contributed to quantum theory by explaining the photoelectric effect, which helped establish the idea that light behaved as both a particle and a wave. Yet as quantum mechanics developed, he became increasingly opposed to its implications. Einstein could not accept the idea that reality was governed by probabilities rather than definite laws. He famously remarked, "God does not play dice with the universe," expressing his belief that nature operated on fixed principles rather than random chance. He also rejected the notion that physical reality depended on an observer's measurement or observation. In 1935, Albert Einstein, along with Boris Podolsky and Nathan Rosen, formulated the EPR paradox, which sought to expose the incompleteness of quantum mechanics. The paradox suggested that quantum entanglement, where two particles, regardless of distance, could instantaneously affect each other, was incompatible with the principles of locality and realism upheld by classical physics. Einstein mockingly referred to this phenomenon as spooky action at a distance. Despite Einstein's objections, subsequent experiments confirmed the predictions and the reality of quantum mechanics. Today, quantum mechanics remains one of the most successful and experimentally validated theories in physics. It has given rise to revolutionary technologies from semiconductors and lasers to quantum computing and cryptography. While classical mechanics still applies at macroscopic scales, the microscopic world operates under the rules of quantum theory, challenging our very notions of reality. The clash between classical scientific thought and quantum mechanics was not just a technical dispute. It was a fundamental shift in our understanding of nature. While Einstein and other critics resisted this departure from determinism, quantum mechanics has stood the test of time. The debate underscored a crucial aspect of scientific progress. Even the most revered theories must yield to experimental evidence. As we continue to explore the mysteries of the universe, the legacy of this scientific revolution reminds us that the pursuit of knowledge often requires challenging the very foundations upon which it stands. So, who won the battle? Einstein or quantum mechanics? Well, the universe cast its vote, and classical science never saw it coming. And as it turns out, quantum mechanics didn't just break the rules, it rewrote them. The lesson? Even the greatest minds can be wrong. Because in science, the only real authority is the truth, no matter how strange it may seem. So the next time you think you've got reality figured out, remember, the cosmos loves a plot twist. But what do you think? Drop your take in the comments, and if your brain isn't completely melted yet, hit that like button and subscribe for more mind-bending science breakdowns. Until next time, stay curious.